All of our exponential functions look like this format. Y equals a times b to the x. This is the same as what you saw for a geometric sequence. So in this equation, the a is the starting point, or the y-intercept. And the b number is the multiplier, or the rate that it's growing by. The x in the exponent is keeping track of how many weeks have gone by, how many years have gone by, how many times are you multiplying by that multiplier. So let's look at an example. Y equals 3 times 4 to the x. If we were thinking of this as a table, the starting point, or the y-intercept, is the 3. From there, the multiplier, each time we go through the table, the next number is going to be multiplying by 4. So if I started at 3, if I multiply by 4, I'd get 12. And then we multiply by 4 again, which would be 48. Or multiply by 4 again, 192. And we can just continue the pattern. In terms of a graph, notice there's not negative numbers here, so the 0th position would start at a height of 3 on the y-intercept. The next one is up at 12. The next one jumps up to 48. The next jumps up way up to 192. This is a curved graph called exponential growth. It can go negative, but we don't typically see those. The other example I gave, again, shows that starting point. Our table is going to start at 10 for the 0th point, or the y-intercept. And then each time after that, the rate is the multiplier of a half, or 0.5. So each time we're going to multiply by a half, or 0.5. So times 0.5, or times half, would be 5. Half of that is 2.5. Half of that is 1.25. If we make a graph of this one, the starting point, the 0th, is up at 10, and then the numbers are going downward from there. So we'll start up here. The y-intercept is at 10, and then half of it is 5, half is 2.5, half is 1. And you'll see kind of this curving downward. The reason that these two graphs are curved is because the pattern is multiplying. And then the reason that the first one is going upwards, increasing, is because the multiplier number is 4. Anything that's bigger than 1, multiplying by 2, 3, 4, is going to be increasing or going upwards. The second one, the green one, looks like it's going downward, and the table numbers are going downward because the multiplier is something that is smaller than 1. So any sort of decimal or fraction smaller than 1 is going to make a decay or decrease. So let's look at a few more examples. Without reading all of the information in the stories, part A is going to ask us to write an equation that represents the data in this table. So I'm bouncing a ball and recording the height. I can see that the height is going downward, and since we're doing multipliers, we're going to try to find that multiplier, and we can work backwards to find that multiplier if we divide. We're going to do 67.6 divided by 84.5. which is 0.8. So our pattern is multiplied by 0.8. So if we start to write our equation, we've got this y equals, we don't know the 0th number yet, and then our multiplier is 0.8 to the x exponent. So to go backwards and find that 0th one, we can just keep working backwards by dividing instead of multiplying by 0.8. And dividing by 0.8 again is 132. We're dividing because we're working backwards or back up in the table. If we were continuing forwards or down the table, we would be multiplying by 0.8. So we'll put our starting number at the beginning of our equation here. And this is our final answer. Part B, we're not going to read the whole story. but we are just going to highlight some of the things that we see. We see this equation. And so it asks us how many people founded the company, meaning what's the starting number? Well, in that equation, the starting number is 3. 3 people started it. And the second question it asks us is, how can the growth of this company be described? After the 3, the number is 4. The multiplier by 4. Every year, it's multiplying by 4. Question C. Again, I'm not going to read the story because I can look at the picture and get the information. I'm looking at the days that have gone by and computers that are getting a virus. And skimming through the text, it's going to ask me how many computers are in the technology center. Well, how many does it start with? Day 0 started with 27 computers. What portion of the virus-free computers are infected each day? How many computers remain virus-free? Justify your answer. So I need to find this multiplier that will take me from 27 to 18. So if I don't know what to multiply by, I just reverse it and divide. 18 divided by 27, which is 0.66, aka 2/3. So that means 2/3 of the computers are uninfected. Last example on this page. As a part of a major scandal, it was discovered that several statements at the prospectus for Expecto Grow in problem B were false. If the company actually had 5 founders and doubled in size each year, what would the equation look like? So we need that y equals a times b to the x. We know that the a is how much you start with. How much did it start with now? 5 founders, so 5. And my rate is that it's doubling. Double means times 2. So it's 5 times 2 to the x power for an exponential. So your goal is to do number 23 here with the equation provided. What is the 7? What do you know about the 7? What do you know about the 2? And then sketch a graph like I did at the beginning of the video. And then the last question is that increase or decrease percent. Reminder that we always start with 100%, and then we can increase by adding more or decrease by going back. So for example, if we increase by 25%, that means I started at 100% and I increased by 25. So now I have 125%. And then to write that as a decimal multiplier, we just divide by 100. And our final answer is 1.25 as my multiplier for an increase. For a decrease, we would work the other direction. We would start at 100, but we're decreasing, so we're going to minus 18%, which would give us 82%. And then we convert that to a decimal multiplier by dividing by 100. And we would get an answer of 0.82 as our multiplier. As a reminder, numbers that are bigger than 1 are going to be growth situations where the numbers are going up and up and up. Multipliers that are smaller than 1, like 0.82, are numbers that are going to multiply and it's going to become smaller and smaller, like a decrease.